Advanced Algebra 2, Quarter 1 Review. We're now up to and working on Unit 2, Transformations of Parent Function Graphs. This is Objective 1, where you will describe transformations with words or from words to equations or graphs to equations. First, we're going to look at the following, okay, where we are moving, and this is 1, 3, 5, 6, 8. I know the number's a little weird. They came from a different review. First, let's go over here the fact that if you have a negative anywhere, you should be saying that it is going to reflect. If you add or subtract, you are moving, translating. If you multiply, you will be stretching or compressing. So those are the only three things that can happen. Now, how do you know what's happening? Well, remember, on the outside, it goes up, down. On the inside, it's your left and right. Now, remember that on the inside, your x lies to you, okay? You can also think about when you multiply on the inside as if it's exercise. If you do a lot of exercise, a big number, you're going to get skinnier, you're going to compress. If you don't do enough exercise, you're going to get fat. So let's go ahead and take a look at 1, 3, 5, 6, and 8. Number 1, y is equal to the absolute value of x moved 3 units left and 2 units up. What does that mean? Well, if I take a look at this, so I'm trying to get my little pen here to work. Is it working? Nope. Okay, so we'll go like this. So what happens is I'm looking right here, 3 units left. That indicates I'm going to be on the inside. Since left, we usually think about subtracting. Remember, on the inside, my x lies to me. It's going to be plus 3. The 2 units up will be on the outside. That's exactly what it sounds like, plus 2. The next one, y equals absolute value of x. This is my parent function. This is the absolute value function. This is going to be reflected, so I know I'm going to need a negative over the x-axis. That's going to flip it upside down. So that's going to tell me that it's going to be outside. And 8 units down. Again, that's an up-down. So that's going to be 8 units down is minus 8. And again, on the outside. So what do? I say y equals negative, that's on the outside, absolute value of x minus 8, also on the outside. Inside would be between these. Nothing's happening left or right. Number 5, y equals x squared. Now I'm using a quadratic. This is going to be reflected over the x-axis. So again, I'm going to think negative, outside, and 12 units left. This is going to be inside. So my negative is on the outside. Well, if I just have x squared, I don't have an inside or outside. So that's where I need my parentheses. So I put the negative, and then I put a parentheses, x. I'm moving to the left. Left is where our negative numbers go, but remember my x lies to me, so it's x plus 12 on the inside. And I can't forget my squared out here. If you forget your squared, or you make it cubed, it's not the same parent function. We want that parent function. Number 6, y equals the square root of x, reflected over the y-axis. Now I've got a negative, and it's on the inside. Because remember, if I reflect over my y-axis, I'm going sideways, which is going to affect the value of x. And 7 units down, that's going to be outside. So now y is equal to the square root. How do I make a negative on the inside? I use the radical and I put the negative inside. And then down will be minus 7 on the outside. Finally, I'm looking at a cubic. The exponent is 3. I'm going to move it left 7, up 6. So left is inside, up is outside. And then I want to vertically, as soon as I see vertically, I know it's going to be on the outside, stretch it by 11. So y equals, here's my multiplication on the outside by 11. That's my stretch factor. The plus 7 is on the inside because I'm moving left 7. And then I'm up 6. Here's my plus 6. Given a graph, write the equation based on a transformational approach from the parent function. Also state the domain and range in interval notation. Well, first, I'm going to look at my graph and I'm going to write my, what is it doing? Okay. I know this is a U-shaped graph. So the parent function is y equals x squared. Okay. I know that's the parent function. Everything starts here at the center at 0, 0. This has moved left 3. I also know instead of being a U shape going up, this is a U shape going down, so it's reflected over the x-axis. So now I'm going to take this and rewrite it. Here's my negative for the reflection over the x-axis. Inside the parentheses, x plus 3, it went left, squared. Now when I look at the graph, my domain, remember your domain is your left to your right. Well, this graph keeps going forever to the left, so it's negative infinity. Forever to the right is positive infinity. We can't put a value on infinity, so I use parentheses. The range is your bottom. Where does it start on the bottom and where does it end on the top? It's all the allowable y values. When I look at this, it goes down forever, so that's negative infinity. But when I'm looking at it, I come up, 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 up. I can see the graph here at y equals 0, but as soon as y gets bigger than 0, there's no more graph. So it's from negative infinity up to and including 0, so you use the brackets. Number 10 is also a quadratic. It has moved from 0, 0. It has moved to the left, or sorry, to the right 4, down 8. So right 4, down 8. Now to check if it's been stretched to compress, I go right 1, up 1. Ooh, if I go up 1, I miss the graph. Well, what if I go right 2, up 2? Oh, I'm on the graph. Remember, normally I should go right 2, up 4. When I'm looking at this, if I look at this right here, I can see it looks like it's about a half, but if I know right 2, up 4, if I see that I'm only going up 2, I realize it's a vertical compression by a half. When you're going from the graph of a quadratic to the equation, do the vertical. So vertical compression by a half. Y equals 1/2 multiplied on the outside because vertical is exactly what you get. X minus 4, the minus 4 is moving 4 to the right. Quantity squared, that's my parent function, minus 8 takes care of the down 8. Again, every single quadratic, every single x squared will be negative infinity to positive infinity for my domain. The range, the bottom of this graph is at negative 8, and it can actually equal negative 8. So it's a bracket. And then when I'm looking at it, the arrows go up forever, so it continues up to positive infinity. Let's look at numbers 11 and 12. These are absolute values. So I know both of these will be y equals absolute value of x. And then I'm going to transform it. I can also very quickly say it goes forever left, forever right, forever left, forever right, negative infinity to positive infinity. Those should be quick, easy, fast ones. Now, let's talk about what's going on with number 11. Again, I start at the origin. It's moved left 4, down 1. So left 4, that's on the inside, down 1 on the outside. Now it looks a little skinny or a little tall. So if I go right 1, I go 1, 2, 3. Oh, I went up 3. Okay. So now I notice that I've got a vertical stretch of 3 because my parent function is 1, 1, 2, 2. It's an absolute value. If I want to double check it, I can go right 2. I went up 1, 2, 3, 4, 5, 6. So I'm 3 times as tall. It's a vertical stretch of 3. So my vertical stretch goes on the outside, multiply. Down 1 is added on the outside, and left 1 is on the inside. And remember, my x lies to me. So I get y equals 3, absolute value of x, plus 4, or that's minus a negative 4, either way you want to look at it, minus 1. I've got my equation. Now, for the range, when I look at this graph, it's given to you. The bottom of the graph is here at negative 1, and there's actually a point there when y is equal to negative 1. So I use the bracket, and it goes up forever, so it goes up to positive infinity. Moving over to number 12. I notice that the graph is upside down, so there's my reflection over the x-axis. I also notice that it went to the right 2 and up 7. Right 2, up 7. Reflection over the x-axis is a negative on the outside. Right 2, my x lies to me, so that'll be minus 2 on the inside, x minus 2. And then up 7, I have plus 7 on the outside. Again, negative infinity to positive infinity, forever to the left, forever to the right. The range, this graph is going down forever, so it comes from negative infinity, but as I'm moving up to the top of it, it stops here at 7. That's the top of it. It can actually, the top is actually at 7, so I use a bracket. 13 and 14. 13 and 14. 13. This is a crazy S-curve. I know this is a cubic. Oops, I don't know why this is. Let me get this so you can see it a little bit better. Oops. There we go. It's a cubic. It's not a cube root. How can I tell the difference? If I go right 1, up 1, If I go right 2, I should be going up 8. 2 cubed is 8. If it were a cube root, it would be this guy kind of on his side because he goes up much slower. Now, the one thing about cube roots, both the domain and range are negative infinity to positive infinity. If you look at both of these, this is going forever to the left, forever to the right, forever down, forever up. Negative infinity to positive infinity. Those should be give-me's on the cubics. Now, again, y equals x cubed. If you need an inside, you're going to do y equals, you're going to do your parentheses, you've got your x, and you're going to put your cubed on the outside. Okay? This one, remember, the parent function is starting here. You go right 1, up 1, right 2, up 8. So you'd have something like this guy going on, and then over here, I'm drawing this with the mouse, so I apologize, it's pretty wonky, goes down like this. This has been reflected over the x-axis. Notice if I flip it upside down, I get this. Yeah, you could say it's reflected over the x, but again, be careful. Don't do that when you're going from the graph, okay, from a graph. So I reflected over the x-axis, and then I'm looking, where is my central point? It went to the right 5 and down 2. Here's my central point. Did it stretch or compress? I go right 1, up 1. I'm still on it. There's no stretch or compress. So here's my reflection over the x-axis. Here's right 5. Remember, your x lies to you. And down 2. For this guy, I notice he's not reflected. I move to the left 2 and up 5. My x lies to me, so the x plus 2 on the inside, plus 5 on the outside. Now, for the final type of questions, you may be asked to describe from a function what's going on. Here, I've also listed the parent pattern for each one of these functions, just so you keep seeing it over and over and over. This is a step function. This is going to look like my little, oops, I'm sorry, this is not a step function. This is absolute value. My eyesight, sorry about that. This is an absolute value. So your parent function is 1, 1, 2, 2. Multiplying on the outside, vertical compression by a half. X plus 2, it lies to me, so it's left 2. Adding on the outside, up 5. Number 2, the negative on the outside is a reflection over the x-axis. Plus 5 on the inside, left 5. This is a quadratic, 1, 1, 2, 4. How do I get my parent function? 1 squared is 1, 2 squared is 4. Another absolute value. Parent function, 1, 1, 2, 2. Absolute value of 1 is 1, absolute value of 2 is 2. The 3 multiplied on the outside is a vertical stretch of 3. X plus 2, that's on the inside. It's adding, so that means I'm moving. Remember, X's on the inside lie, so it's left 2. Positive 2 is to the right, but it lies, so I'm actually going left. Here, I've got the square root. 1, 1, 4, 2. I jumped not to 2, but to 4 because the 4 is a perfect square root. The square root of 4 is 2. The square root of 2 is 1.4. I don't want to try to graph that. I want nice numbers for graphing. Again, multiplication is stretching and compressing. On the outside, it's what I see is what I get. So 4 is a vertical stretch of 4. A negative on the inside will reflect horizontally or over the y-axis. Adding on the outside, adding is moving. Outside is what you see is what you get. I go up 5. Number 7, again, is an absolute value. 1, 1, 2, 2 is my parent function. Negative on the outside. Reflect over the x-axis. Okay, if I reflect over the x-axis, I'm going upside down, so I'm affecting my up, down, or my vertical. Multiplying on the inside by 7, I did 7 times the exercise, so I'm going to get skinny. Horizontal compression by 1/7. You can also think about the fact that x lies to you. You're not 7 times bigger, you're 1/7 as wide. And then subtracting on the outside, I'm moving down 5. Number 6 is a cubic. 1 cubed is 1, 2 cubed is 8. There's my parent function, or my parent pattern. Plus 2 on the inside, left 2. Minus 9 on the outside, down 9. Inside, left, right, outside, up, down. Number 7, this is your step function. When we graph it, we think about our jump and our step length. Here, I'm just asking you to describe the transformation. The transformation here says that a negative on the inside will reflect over the y-axis. This is going to result in my open dot being to the left and my closed dot on my step on the right. Multiplying by 6 on the inside, did 6 times the exercise, I'm 1/6 as wide. Or you can think about it as inside lies to you. Instead of being 6 times wider, you're 1/6 as wide, or you had a horizontal compression. There's no adding or subtracting, so there is no movement. Number 8 is a square root. The square root of 1 is 1. The square root of 4 is 2. Looking at this, I've got a negative on the inside, so I'm doing a horizontal reflection, so I'm reflecting over y. Multiplying by 5 inside, inside lies, x lies, horizontal compression by 1/5. I got the 1/5 by taking the reciprocal of 5. Flip it upside down. I'm adding on the outside, so it's up 2. And the last 2, I have a cubic. 1 cubed is 1, 2 cubed is 8. 1/4, if there are no parentheses, you are by default outside. Outside is what you see is what you get, so your 1/4 is tall or a vertical compression by 1/4. Moving it up 19. Finally, number 10, again, is a step function. You could think of this as you're jumping by 2, and you would have your y-intercept. But since we're just asking for the transformations, the outside vertical stretch by 2, on the inside, okay, oops, on the inside, this is wrong. Look at that. On the inside, you're going to go left 8, okay? Left 8. Why? Because x minus 8 means you're going to the left 8 spaces, okay? All right, that is it for this objective.